Okay, let's talk about more about proofs. Okay. So this was a pretty simple one. We actually did this last time. Initially this was similar, but now they're asking to prove these are congruent. So I think it's pretty obvious. You could just say, well, AB equals FD, right? I mean, just look at it. They both equal 6. BC equals DE, both equal 4.5. So again, just look at it. AC equals FE. Again, just look at it. And you can say it's given. And because all three pairs of sides are the same, can we say the triangles are congruent when all three pair sides are the same? And for what reason? There we go. Done. So triangle ABC, make sure you state it in the right order, is congruent to triangle FDE. Oh yeah, this is too easy. This is way too easy. Yeah. Oh yeah. But the next one's a little more reasonable, I feel. Okay. But this is just to kind of just get you guys warmed up. Like, okay, cool. Like all three pair sides are the same. That's enough to say they're congruent, right? We have enough information. But sometimes you have to dig a little deeper, right? So 631 will force us to dig a little deeper. Before you get too carried away, I always like to kind of talk myself through it and say, okay, well, I know these are the same. And for what reason? Not reflexive, but vertical angles. Reflexive one's the same exact thing. Like there's like a shared side or a shared angle. But yes, these are the same. Um, and of course, I know angle P equals angle T. Of course, I know PQ equals ST. So what I could do is I could say um, angle P is congruent to angle T. At the same time, I could also say PQ is congruent to segment ST. And both those are given to us. You can actually combine those in one step. You can write two separate steps too and call it given twice. I don't care. But then don't say this. You don't want to say angle R equals angle R because angle R could be PRS or PRQ. So you want to be a little more specific here. I'd say angle PRQ, because that's a smaller angle, right? Is congruent to angle SRT. The order doesn't matter so much as long as R is in the middle. And what's the reason? Vertical angles are congruent. And lastly, triangle PRQ. You have to do states in the right order. So P's at 120, R is the middle, Q is this last one. So I'd say, how would you?
TRS.
Good. Yeah, that's correct. A triangle TRS. And what's the reason for that?
Because if you line them up,
Correct. Yeah, angle side, because the side's not between the two angles. You have two angles for sure, two pairs of angles for sure that are congruent, and you have a pair of sides that's also congruent, but the pair of sides is not between the two, so you have to put it outside. So yes, right. Congruent zero. I also think that's a little too easy. Ooh, that's a good one. Next one comes really good. Okay. Um, so let's see here. 632. Okay, so first off, determine if each pair of triangles are congruent, similar but not congruent, or just neither. If you claim they're similar or congruent, let's make a proof. Okay. I'll tell you that two of these are okay, two of these are not. So which two are congruent? Look at let's take a look at B. Well, that's those sides are not the same. Yeah, so that's no. Not congruent. Hey, oh yeah, no worries, you're good. Yeah, you're good. It tends to take care of it. But they are similar. And that's because that angle equals that angle. Um, but you can't say they're congruent. So yeah. But you could say they're similar because they have vertical angles and you have 50 degrees. Yeah, 50, go ahead. We'll get to A in a moment. Yeah, yeah. Okay, what about A? What do you guys think? Are those congruent? Yeah. So this side is shared and angle D equals angle B. And also that equals that. Why are those equal, those angles? Good. Yeah. So we're going to prove this one. We're going to do a proof for that one there. That'll be a good one. Actually, I like that one for a proof. That's a really good proof. Okay. How about part C?
Why is it PROOF? Like if you say to prove, but if you're trying to prove it.
We're gonna prove it. What's
ROOF.
the proof? Yeah.
But then it's like you have to prove it.
That's semantics. I'm not going down that path. You're talking about a verb versus a noun. I don't care. Whatever you want to say, it doesn't matter to me. Either write a proof or prove it. Same thing. Okay. All right. That's all right. It's okay. It's okay. For part C, that's no.
It's not similar either.
Right. Yeah, it's not gonna be similar because what's gonna happen is if I redraw the triangles, where that's 3 and 6, and that's 2 and 3. Are those sides proportional?
No.
Yeah, 2/3 does not equal 3/6. So yeah, forget about it. That's not gonna work. So we won't worry about C at all. For D, that is yes. And that's side, side, side. And by the way, for part A, that's going to be angle, angle side.
How is it? Side, side, side for D.
Because all three pairs of sides are the same. If you do Pythagorean theorem. Yeah. Yeah, that's just a reference. All the different reasons you could use for proofs. Okay, for the proof we're going to do on this page, let's do it for part A, because part A I think is a more reasonable proof that I could ask on the quiz next week. It's the kind of proof that we like. So actually, let me do it off to the side here. You guys have plenty of space down below. So we'll prove part A. We'll do it right here. Okay, so when you make a proof, you do 2 columns. You do statements and reasons. So we're trying to prove the triangles are congruent. So first of all, what information was provided to me in the diagram that was helpful? Well, we're told that AB is parallel to what? Good. AB is parallel to DC. Awesome. So that's given. Is anything else given to us?
angle ABC is
Correct.
equal to.
And if you want to just say angle D is congruent to angle B, that's fine. Because it won't be ambiguous because there's no other angle D. If angle D could be another angle, then of course we should be more explicit. But yeah, angle D is congruent to angle B. Okay. So those are explicitly told to us with the markings. And by the way, we would actually even state, here's what's given. And then you just copy it. Okay, now when we said AC is a part of both triangles, right? Because there's two triangles we're trying to prove. They're the same, and AC is part of both of them. What do I say about that? When I say AC equals AC, what's the reason for that? Yeah, you say reflexive. Because anything, of course, you'll always equal itself. It's like a reflection in the mirror, right? You see the same thing. And technically you should say this. Reflexive property of equality. If you just say reflexive, I'll give it to you. But just as a formality, you might see it as an answer key, reflexive property of equality, because you're saying two things are equal due to the reflexive property. But if you say reflexive, I know what you mean. So that's all good. And then see, this is the part of proofs that sometimes is a little tricky. You have to use provided information to see what leads to the next information, right? Like when two lines are parallel, what leads from that? What's the next logical step when two lines are parallel? We could say the angles are the same, right? So that's logically what follows. What two angles do we say were the same? Angle what equals angle what? Yeah, and you have to be explicit because you can't just say angle C because it could be two different angles. So you want to say angle DCA is congruent to what other angle?
BAC.
Perfect, BAC. And when you say that, you want to give the reason as detailed as you could. Alternate interior angles congruent. But if you just say that, you're not going to get the full point because alternate interior angles could exist for any pair of lines, but they have to be specific for what kind of lines? Pair of lines, yeah. For example, if I were to draw this here, well, I'm going to deliberately draw two lines that are not parallel. Those are alternate interior angles, but are those the same? No, because those are not parallel lines. So you can't just say alternate triangles are congruent. That's not sufficient. You have to add the part about parallel lines. Otherwise, they'll give you half a point instead of full point. So you got to be careful about that. All right. And then lastly, do we have enough information to say the triangles are congruent? We do. And you have to say in the right order. So triangle, if we say DCA is congruent to a BAC. And that's what reason again? Yes, correct. Good. Good. Okay. All right. So I think we're okay there. Okay. Um, so let's move on to the next page. And then I want to show you guys some more advanced proofs after we finish these notes before you guys start homework. Okay. Let me have someone do some reading, give my voice a little break. Reagan, can you read 633, please?
Triangle UW is congruent to triangle XYZ. But can you include the sides and
Yeah.
angles? Triangle UVW and triangle XYZ. Write down every equation involving side lengths or angle measures that must be.
So this is going to be a very important problem because it kind of leads us to another theorem, which we'll talk about in a moment. But let's just draw two identical triangles. Okay, so you know that these are congruent. Great. XYZ. UVW, right? Oh, the color palette is covering. Sorry. Sorry about that. Yep. Okay, so yeah, we know that this lines with this, right? This lines with this, and this lines up with this. So what can I conclude? Is UV congruent to XY? Yeah, of course. Is VW congruent to YZ? Yes. And lastly, is UW, and the order in which you write these letters doesn't matter. It's only for triangle congruence we care about that. Text C, yes. So when you make this statement, this is something called CPCTC, which stands for, I'm going to write this in the text box. Corresponding parts of congruent triangles are congruent. There's something similar for similar triangles. Yeah, it was like corresponding sides of similar triangles are proportional to CSSTP, and the other one was CA, corresponding angles of similar triangles. That was CASTC. Yeah. But if you look at it's a bit of an acronym in a way. C P C T C. So you would use this once you establish. This is very important, actually, and I really need you guys to be present to this because a lot of people get this confused, and they think they think this is used to prove triangles are congruent. It's not. You use CPCTC once you have established that two triangles are congruent. Very important. You only use this once you've established that two triangles are congruent. That's when we actually use this that theorem. Corresponding parts of congruent triangles are congruent. Once you establish the two triangles are congruent, then you can say, oh yeah, and then these sides are these angles. And by the way, it's not just for sides. It can also use for angles as well. So I don't want to doctor up the diagram too much. So let's look at the angles now. Is a question? Question?
Okay.
Yeah, go ahead. Yeah.
Like, right, like all the things like A, S, or can you just say like B, P, C, T?
Well, sorry, say again.
And can you also like a table of the side and be like, this shows that.
Well, let me show you a proof. I'll answer that question will be answered once we get to a proof. You don't have to say it for all the sides. I'm not sure if that's your question. It's really more just in a proof. Like if you have to prove like a pair of angles, a pair of sides are the same. It's after you've established the congruence for the triangles. Correct. Yes. Yeah, sure. Yeah. All right. So let's look at this. Yeah.
The sides are congruent.
No.
Piece,
No.
even though like.
I mean, just make sure it lines up with the right side. That's all.
Yeah, I know, like, do you?
You mean the lettering, like UV and yeah. If you say UV YX, I don't care, or VU XY.
Why?
No, because those are not the same.
Okay.
Yeah. Correct. Right. Yeah, exactly. So let's look at these markings. Angle U is congruent to what angle? X. Angle V is congruent to what angle? Y. Angle W is congruent to angle Z. Also, that's CPCTC. Because are these corresponding parts? Yes. Are they part of congruent triangles? Yes. Therefore, they're congruent. So U and X are corresponding parts. V and Y are corresponding parts. W and Z are corresponding parts. These are corresponding these are sorry, triangles. So naturally these have to be the same. So we're going to see this in action in a proof in a separate worksheet in a moment. Okay, so hopefully that's okay there. Let's read this one here. I don't see it filled out, so I'm not sure if we really do this one, but for 644, information overload. Raj is solving a problem about three triangles. He's trying to find the measure of angle H and the length of HI. Raj summarized the relationships he has found so far in the diagrams below. Okay, so okay. So I think he should be okay. Bring this out. So what do you think angle E is going to equal? Well, first of all, what can we see about triangle ABC? It's congruent to what a triangle? DEF. Because of what?
Oh.
Well, we SSS, because you know that this lines up with this lines up with this, and of course these are both 5 centimeters. That's how I know that. Also, triangle DF is congruent to what a triangle? Yeah, the GHI because of SAS. So naturally, ABC has to be the same as GHI. So if that's true, then by CPCTC, angle B is congruent to what other angle? Exactly, correct. So these are both 60 degrees. And what sides are the same? BC is the same as what side? EF and HI, love it. Good. So that's also 5 centimeters. Yep, that's it. Okay. So that's another way of looking at CPCTC. So you have to establish that the triangles are congruent by all the things you've learned. Side, 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 angle, side, angle, side. What's the other one? Why am I forgetting the other one? Hypotenuse leg and why am I going blank? Side, angle, side, 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 side. Oh my gosh. Yeah, I just said that one. There's 5. SAS, AS. Why am I going crazy?
SSA.
Yes,
ASA, thank you. Yeah, I know it's going crazy. ASA, thanks. Appreciate it. Yeah, ASA. Side angles only for hypotenuse leg theorem. We have a right triangle. So, okay. So the homework that you guys will work on, we still got plenty of time, but before we do the homework, I just want to show what the homework is, and then I want to do a couple more proofs so you guys feel confident doing the homework. So homework's going to involve, oh, that's calculus or pre-calculus. So for homework number 2, you're going to be doing some textbook problems, not terribly many, like it's pretty short for the textbook problems. But I also say here, you're going to do number 2 and the triangle proof handout. So you guys have another handout. It looks like this, triangle proof handout. It should be actually in the homework packet, I believe. Does someone have the homework packet? Can I look at your homework packet? Yeah, I think it should be. Oh, it's a separate handout. Yes, you are correct. It's a separate handout. Yes. Yes, it's a separate handout. My apologies. Yes, good. Thank you, Reagan. Appreciate it. So we'll do number 1 together, just so you guys get comfortable with labeling these things. And then I'm gonna I won't do number two necessarily because I want you guys to do that on your own. But I do want to ooh, H is a good one. But I do want to talk about CPC/TC with you guys. So we'll just go through this warm up here on identifying why these are congruent or if there's not enough information. So let's knock this one out. Okay. So let's look at the first three. I'll have you guys do the next 9 in your table groups. So do we have enough information to say these are congruent? Yes or no?
Yes.
What reason?
Angle side.
Angle angle side. Yes, that's correct. Angle side. And the congruent statement would be triangle DOG is congruent to triangle CAT. And that was kind of done on purpose, dog and cat. Yeah. So the dog is congruent to the cat. Okay. What about the second one?
SSS.
SSS. Yep. Because PN is shared. So triangle NHP is congruent to triangle NXP. Okay. This one's pretty obvious. What do you guys say for that one? Yep. Side, side, side. Triangle SOL, which is an acronym for, you know what, I don't have to say out loud. If you're SOL, shit out of luck. You never heard that before? Okay, I said it out loud. Okay. SOL? Yeah, anyway. VD, I don't know what that stands for, but anyway. That was just random. Or it could be Spanish soul means sun. Sure, whatever. So anyway, SOL, VED. Those are the same. Okay. Go and try the other 9. We'll check in a moment. I'll freeze the screen. I'll show you what I get for these here. There we go. Just in a twos will be not enough info. Geez, I can't read that fourth one. What the heck is that letter? What is that letter?
Red N.
Sure. Yeah, I'll go with you. Yeah, I'll go with that. Okay, then mine's messed up. Guess I'll get so far for those six. If you guys disagree, let me know. We're okay. Yeah, definitely have ASA for the top left one there. Then you have SAS there. Then you have non-information angle. It's not a thing. ASA because you have the vertical angles here for the fourth one. You have SAS for that one because you have the vertical angles again. But the last one, non-information side angle. That's not a thing. We can't really say that. Let's say have right angles. Yeah.
Angle like O and P equals angles and PE.
How do we know that? No, not parallel. We don't know that. We don't know that. You just know they're congruent. We don't know if it's parallel. We just know they're congruent. You need the arrows. We don't know that. They look it. They look it, and there's a good chance it probably would be, but we have to have that information. So we that's why it's not enough information. Yeah, now if I had this here, actually, give me a good idea for a really good test question, Colette. Thank you. Um, yeah. Now, if they're parallel, then you can say that, right? And then you have the reflexive, then you have ASA afterwards.
Okay, so that like the arrows, that also means it's parallel, or does it not go both ways?
No, that means a parallel. That's it. Arrow just means parallel. The markings means, but I will tell you that they're parallel or congruent. I'll tell you that. I was explicitly say so. So you're not like guessing. But the markings are also a tell. All right, let's look at the last three. Okay, the last three, I'm going to freeze the screen again. Switch to red here. Actually, the first one, the last row, is exactly what I was talking about. I heard angle side. That's a good sign. Ooh, that second one's a good one. That is crazy. It's gonna be all right. I think I got this. It really helps if you flip one of the triangles in the second grouping so they match up. I kind of did some color coding to help see that the sides are the same and the angles are the same. So all these are congruent. All these have enough information. For the first one, that's going to be angle side. because you have the parallel lines, so you have the the alternate triangles that are the same. So you have angle on the side. And then likewise for the second pairing, you also have angle on the side, but it helps if you flip ROT so it matches ACN perfectly. And I should have redrawn the other pair of triangles, the first and third, but it's okay. But I can see I get a side angle side for the last one, last pairing. Yeah. Hmm?
Same.
SSS. We don't know if ME equals RB though, right? We don't know that. But I do know because of parallel lines, right? The arrow markings. I know these are the same angles I did in purple. And ER equals ER, right? So I know that.
Because the other people are also here.
Actually, I think you are. Wait. Oh, you mean? Wait, which one? Which first, second, or third? Hold on. Oh, you're saying that this is the same as this? No, because you don't know if these are parallel. You don't know that. I don't know that. So if I had this here, then sure, go ahead and do that. But I don't know that. So
But wouldn't it just still be if those times of parallel? There's so we can do.
um wait, which lines? Yeah, show me. Which lines? Oh, the angles you mean.
Or like parallel.
Right.
Fine, wouldn't this still also be convenient?
Um oh, hold on. I see what you're saying. I think my eyes are playing tricks on me. Oh, I see what you're saying. Yes, you are. Wait, no. Well, you know that this is the same as this.
Oh.
Yeah. Yeah, you would know that this right here, but that's not part of the diagram. So yeah, that's all you could all you could do. I see what you're saying. Okay, let's look at one more type of proof and you guys can work on homework.
Definition of the thing.
Let's do 2B, it's fine. Yeah, let's do that one. Okay. Um, okay. Um, yeah, so you know that PL, this is part of homework, so I'm doing this part of homework for you guys. Is going to the YL. Great. Also in a point A, is midpoint PY. So here's the deal. If A is a midpoint, what does it mean about PA and AY? Correct. And LA equals LA.
Statement.
Point A is a midpoint. I'm just repeating this. I'm just repeating it. That's all. So now you know the triangles are congruent. A, B, C, D, E, F, G, H. Not IJ. Not IJ. Yeah, I think it says so in the homework. I think it's just A through H. Hold on.
Yeah, another one.
Yeah, but it's not much. So, um, yeah. Yeah, so homework 2 says, hold on, my notes are all messed up now.
Mr. Marshall, I think are so easy.
Okay. So we'll go and stop there for today for a lesson. So you guys can work on the homework. So the homework is going to be um yeah. So the textbook problems and then the triangle proof handout.
Okay, so
Yeah.
like.
Yeah. There we go. I think it's A through H. Let me go Schoology really fast. I need to refresh this also. Yeah, it's just A through H. Yeah, yeah. And you guys have the answer key, by the way. Now you do. Yep. Yes.
Oh my God. Which one you want?
Yeah, and it says so right here in Schoology, the homework. So homework. This is due on Monday. So due on this fall. Yep, and the homework's been posted at Schoology, so you can submit whenever you can. So yep. Mhm.
For this one.
Mhm.
Is this the one where you like the C?
No, that's for triangle congruence still. You're gonna do side angle.
Side angle, sorry.
Yeah, side angle side, yeah, because these angles are the same.
Wait, so when do we
Yeah.
use the other one?
Actually, you probably won't be using it until probably part D. I think part D is when we use it. Let me see here.
And like, well, why do we use that one?
Because once you've established triangles are congruent, you want to show that other parts of the triangle are the same. The
Oh,
corresponding parts.
So that's if you like want to prove a certain part is
Correct. Right.
Okay.
Right. Yeah, you guys can see PCTC once in this homework.